All right, I did this question, but give me that answer that we got again for this. 163,91. Okay. All right. The moon is the Earth's nearest neighbor. The distance between the center of the Earth and the moon is 3,84 times 10 to the power 8 meters. Mass of the 7,5 times 10 to the power 22. State Newton's law of universal gravitation in words. I have people who are waiting for the night before exam. Guys, let's learn those definitions one per day. Is that okay? One per day would work a lot. And if you forget, let me show you how to remember. Get those things. You know the formula. What's the formula? F equals to what? G M1 M2 over what? R squared. Don't worry about the G. What is the F? It is the magnitude of the force between, right? It is the magnitude of the force between the two what? Objects. Now, this is all I needed to remember. That force is directly proportional to what? To the product. And this is the same as your Coulomb's law. Remember Coulomb's law? No. See, if you don't remember this one, you cannot remember the Coulomb's law. All right. But once you get one, it's buy one get one free. Yeah. You buy this one, you get Coulomb's law free. You buy Coulomb's law, you get gravitational free. That's how it works. There's just a slight difference between them. This one refers to the masses. Coulomb's law refers to the charges. This one is the distance between their centers. Why? These are big objects. Coulomb's law, when we talk about charges, we say the distance between them. Why? They are very small. You cannot. So, F is inversely proportional to that. The magnitude of the force, okay? All objects on the earth exert a force of magnitude. You must put the word magnitude. Directly proportional to what? The product of the masses, and inversely proportional to the square of the distance between their centers. We are done there. Calculate the force exerted by the earth on the moon. We're simply using that formula. F equals to what? G M1 M2 over what? R squared. Do we know G? 6,67 times 10 to the power negative 11. Now, M1 becomes the mass of the earth, and that's also a constant value. 5,98. Or, do we know the mass of the moon? Yes. What is it? 7,5 times 10 to the power what? 22 over. What is the distance? This is where the key is. Gemini gave us the distance between their centers. I'll tell you where you are likely to make your mistake. I'm very conscious of it now. You know what my error is? I didn't square. So please take note that error is it's a subtle error that anyone can make, you know, especially in an exam you are aiming to finish. What's your answer? What's your answer? Is that what you got? All right. What is the magnitude of the force exerted by the moon on the earth? Third law. If ob- we did a question like this last week. 5 times the one that you all did. All right. Okay. So our answer here would be same as 5.2. Why? We are using what? Newton's third law of motion. If object A exerts a force on object B, object B in magnitude but opposite in. Right. Beautiful. There we go. ESCOM stuff. Let's give you 10 minutes. Because if I say 10 minutes, they'll start negotiating. Even before they start, just add 2. Not teaching you to start negotiating. Just accept. No, they do that a lot. They start negotiating. All right. Did we manage to walk through? Let me know. Done, 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 not done. Quickly. Done, done, not done. Talk to me. Let me know. I need a feedback from you guys. Oh, done. Amara, lovely. Amara, can I ask you to send me a picture of your work since you're done? Oh, she said, okay, sir. That's I actually thought you were going to start laughing. Wow, so, okay, lovely. Quickly, you skipped 9.1.2. Oh, okay. All right, we'll see. Who else? Divine, Sikulile, Gugu. Come on, Minentle, Angela, Mpo, talk to me. There's so many of you in the house. I need answers. Tina, give me a quick feedback. I want us to do some multiple choice. Patu, are you done? You're stuck. Where? Okay. Too busy with the last one, Sikulile. Guys, can I please get response so we can move forward? Minentle and the rest. All right, let me see. Mara just confidently sent me her answers. Beautiful. Thank you so much. I love that. And then she starts laughing. What I've been waiting. Okay, our first answer. Seven comma five. What do you have? What is 9.1.2? 3. Okay. Mara has 8 ohms. That's for the. Oh no, she has 1 ohm. Sorry, she's got 1. Okay, all right, we're gonna check. We'll check together. Stop laughing, child. Let's see. We're gonna do it together. All right, let's mark. I need to send this child back to the dentist. She eats. Okay, let's see if you and your Doritos got the answers right. All right, let's say in a circuit diagram below, the battery has an EMF of 12 volts and negligible internal. In grade 12, that internal resistance is no longer negligible. Resistance of R is unknown. When the switch is closed, the ammeter reads 1,5. When the switch is closed, calculate the potential difference across. Now, look, this is what I love you to do. For you to be able to do your electricity questions without stress and you without being stuck, this is what I advise you to do. Well, this is what I do. And I promise you, it has never failed. What I do is I try to quickly look at the direction of the flow of current. Once I get that direction, I'm trying to. Now, I get the direction. Current would flow from the right, from the positive to the what? Negative, right? So current is going this way. Now, when current gets here, what happens? It's going to divide. Every time current divides, we talk about I have here is parallel. But what I have here is what? Series. Current gets here, divides, one portion goes here, one goes here. But when it gets here, what happens? It combines. Check. I wanted to see the smartness of this thing now. Means my 1,5, when it gets here, it divides into 2 that I don't know the value. Is that okay? But when it gets here, it combines and becomes what? 1,5 back. Current flowing through here is 1,5. Look, if you learn to do what I just did, you'll be shocked how many questions you've answered just by picking. And then you write down this acronym, if you remember. South African Police Department is what? Paid. Series are potential what? Dividers. Parallel are current dividers. Right. Okay. Series are potential dividers. Parallel are current. But so once you know how to use that, whether grade 10, grade 11, grade 12. Now, check. What's the total? Okay, by the way, can I redraw this circuit for you? That in the exam. I have that as my 1,5, right? Can I combine all of this parallel? Check, I can have that. This is parallel block. I have this. I don't know if this is making sense. This is what I did. Parallel and just put them together. That's a kind of a more simplified. How are those two connected? What do we know in series? What do we know? Series. Series are potential what? Divide. So they take potential difference and divide. Aware that I can quickly calculate the potential difference there. That's the only thing missing. So I in the 3 ohms, R of the 3 ohms, which is what? 3, 5. And that is 4,5. The one here. What is the total? 12. That 12 is being divided. So already the 3 ohms is taking 4. What is the leftover? The parallel becomes what? 12 minus 4,5. And what's your answer? 7,5 volts. I hope this makes sense, guys. Most of the time, I know our issue is we're thinking already now, all your answers are in place here. Resistance, did you get it correct? What was your answer? Resistance of the resistor. Okay. What do I know? That resistor is in the parallel block. This is where we're differing in our answers. That resistor is in a parallel block. That I know the total voltage there in the parallel. What is the total current there? There are different ways of doing this. what we have. We have a 6, 12, and we have what? What are we looking for again? We're looking for the value of R, right? Entire system. What do you know? In this entire block, what do we know? 7,5 what? Volt. What else do we know? The total in that entire block is what? 5A. Like I said, there are two ways. I can get my total resistance if I want now. What is the total resistance going to be? Parallel is equal to I in the parallel multiplied by the parallel. What's my V? 7, R parallel. Make sense? What is R parallel? Let's divide. 7, means the total resistance here is 5 ohms. That's not our final answer yet. Okay. Now, I want to see if I can do this for you in about 2 ways. I can. Let's combine this R series. How many resistors are we going to have? Now that they are parallel, how do you calculate the total resistance in the parallel? R parallel product over what? What is the total resistance? 5. What is the product? 6 over. What is the sum? Plus RS. 5 times 6 will give us what? 5RS equals to what? 30 becomes what? The sum of the series. Go back to my series now. My RS is actually 12 plus R. 30 equals to what? 12. Let's try another method. Try something else and see again. But what I did, I don't know if it makes sense. Before you write, or we take pictures at the end, try something else. Guys, what is the potential difference here? Parallel potential difference remains what? Let's study the 6 ohm resistor quickly. Know the voltage in the 6. What is the current? Nope. Know the resistance? 6. What is the current in the 6? 7. We know the current passing through this now. 1, what? 258. But remember current splitted when it got here. Rest must go in here, which is what? You are supposed to get the same answer. Check. I now have this line. Have this. This is 12 ohm. Total potential difference here 7.5 volts. Guys are connected in series. Current remains what? Divine says 4.5, not 4. Are we okay with this calculation? Let's just check. 7. Confirm. If we don't get the same answer, then we'll know. Right. Now that I know the current, what do I know? Current here is what? Same current is here. Don't forget, these things are connected in what? Get the potential difference in the 12 ohms. 12 equals to what? 12 R12. What is I? 0.25. Do you have an answer for me? It means the voltage in the R will be 7.5 minus IR. What is our V? 5. What is the current? I don't know which method you used and where you. You are using this. We are using this one. And where did you? Divine, are you okay here? You said 4.5 and not 4. I'm not sure what you meant. What method do you prefer? Let me know, guys. Give me a thumbs up if you are okay. For the voltage of the series. Well, far so good. We are okay here, Divine. Voltage of the series. Check. Because I still have the same answer. You are lost. Let me quickly know so that we can find you quickly. Once you have all of this out, 7.1.3 becomes easy. Because you know the current, you know the voltage, you know the resistance. Right? What's our answer for? Let's fix it now. Let's use this new answers. What's our answer for? What should our answer for 9.3 be? Okay. Quickly says there's a request. Let's go through the first method again. All right. Here's the first method. The first method was to find the total resistance. Is that okay? First method was to find the total what? Resistance. So I know the total voltage here as gave me the total resistance as what? 5. But then I see these two. But I used what? R series. I simplified my diagram and I got something like they are in parallel. How do you get the parallel product over what? Sum. You multiply them and then you add them. What is the product? Product is to multiply 6 RS. What is the sum? 6 plus RS. But that is the total resistance, which is equal to what? Cross multiply, that gave me 30. We are saying 12 plus something should give me what? 30. What is that value? 18. Okay? Did that make sense? Somebody please take a picture and send on the group. Take a picture of this quick. Ara. Imagine take a picture. Take a picture, please. Dollar what you must dollar. And take a picture quickly for me. I want to take a picture of the two methods. Is that okay? So we. All right, and I want you to notice everything. Every time I keep writing on my diagram and putting the values. 10.1.3 very easy for me. What is the power? What is the IV? Can we use that? IV now. All right, they keep the quiet. Can we use that? I do that in class when they keep quiet. All right. So, bishops, what do you do? At the power, since we're looking at the power. All right. P6 would be equal to what? We can use IV, but you're using 6, or you can use what? I squared R. You can even use V squared over. The formula page will always guide you. And what informs your formula is the information that you. Can we use IV? What is the I? 1,25. And what is the V? 6. 7,5. What's your answer? 9,34. And what is the unit of power? 8. What is the unit of power? I wasn't asking. I was telling you. I keep doing this. I remove this and it. Because they're offline. Because I removed that. Now they'll be fine out. We'll be connected in the next 1 minute. Just need this to. Okay, guys. 9.2 now. 9.2. The 3 ohms resistor is now removed from the circuit and replaced with a conducting wire. How will this change affect the ammeter reading? Look, all you need to do here to answer this question is to check how your total resistance is behaving. Okay. How the total. If we remove resistor from a series connect, so I would answer by saying total resistance does what? Decreases. R is in, therefore I will what? Increase. Must know. Let me quickly give you a list of the things that would reduce. Total resistance will decrease. For one, if you remove R will what? Decrease. Add a resistor. Okay, I'll check. Somebody just sent me a message. In parallel. Was that a hand? You cannot see. Let me check. What's up? Let me reshare. Can you see now? Quickly. My side, it says you should be able to see. Can anybody just confirm if you can see my screen so that anybody, somebody. Guys, can you see my screen? Buddy. Lovely. Thank you, Amara. So, quickly, it's your side. Okay. All right. So, what are the things that will decrease your resistance? Number one, if you remove a resistor in what? Add a resistor in parallel. And number three, check number three. If you decrease the value of any of the resistors, take note of point number three. If I decrease the value of any of the resistors, all right, and the opposite, just this with the opposite. I want to increase R, what do I do? Add a resistor in series, parallel, and what? Increase the value of any of the resistors. What happens, therefore, is this. R and I are what? Inversely. R goes up, I goes down. If your R goes down, then I goes up. Okay. So that's the main thing there. Is that okay, guys? I hope you know your short circuit. I take a wire and connect across. So check this. If I have my circuit like that, I have a resistor, light bulb. I take a wire. That's called a short circuit. Light bulb would go off. Why? current and resistance. Current comes here and gets here. Current would see that there are two pathways. One, there is zero resistance. Remember, the lesser the what? Resistance, the higher the current. Now we have no resistance. All the current just goes there. Current behaves like learners. I say, guys, I have a school where you don't write exams. Everyone is running there. And if I say, guys, I have a school, if you're in grade 11, you write grade 12 papers. No one will come there. All right. So the higher the resistance, the lower. So this is. Let me give you a good example of this. When you are doing is this is like current would come here and go this way. That's the principle of short circuiting. Wire is placed there. So once you put in that metal part of the seatbelt, you are simply on that switch closes, this light then goes on. Okay. Are we okay there, guys? Let's quickly calculate the cost of electricity. I'm done there, it's 2 marks. All right. The kettle is rated 2000 watts. Calculate how much it will cost 5 hours. If 1 unit of electricity is, when it comes to calculating cost, price kilowatt hour. Actually, power times time. The power must be converted to what? Watt, and the time must be converted to hour. Let's see. Power is 2000 watts. We have a problem. 5,000. Okay. So, what's our unit price? 1 rand 2 times. Our power is 2000 watts, but it must be in. I can say 2000 over 1 just to. So, and how many hours? 5 hours. That's how we calculate cost there. That's very important in calculating cost. Power must be in kilowatt. Okay, there we go. 5 marks. I don't know why I just saw this and I took it out. 5. That. Able to do my multiple choice today. Yeah. Okay, sorry, let's just go back. It says 9.1 power, 9,38 watts. You might be getting something different if you use I squared R. Times because of running off. Okay, quickly, I hope you're okay because already you are chowing your. All right, let's see. Challenging. I just saw it and I thought it could be a very interesting question. Let's quickly run through. All right, let's run through. And having run through all of this, guys, we would have covered the whole section of physics. Charges magnitude 6. The first thing, guys, I don't work with this micro. I need to convert that. How do we convert the micro? Are placed 100 millimeters apart. What do? I divide by what? 1,000. When an electron charge negative placed at point X, it means there's a negative charge. Distance R to the right of 6 is 0. What comes to your mind when you see acceleration? F net equals to what? M multiplied by 0. It means the net force is equal to what? Okay, the first step done. Second step is to draw your free body diagram. Okay, you have our focus is on the electron, right? Let's look at the 6. The 6 is positive. Based on that of the 6, the electron should go this way. I'll call. What about the 15? What's it doing? Also attracting the what? Electron. Okay. F what? 15. I would say F net, therefore, will be equal F of 15 plus minus, is that where the minus came from, right? Now, what is my F net? My F net is what? 0. Go to F of the 15 minus F of the 6. I move the F of the 6 over. F of the 6 on the electron will be equal to what? F. Because it means we are pulling on what? Acceleration. So we said F of 6 will be equal to F of 15. K, Q of the 6, Q of the electron over R squared between the 6 and what? And the electron. What? K, Q of what? The 15. R squared between the 15 and what? That's all my subscript is just for you to see. Okay, guys, I want us to be smart. Get to a point like this. I have K on both sides. It can cancel out. It's mathematics. What else can cancel? Charge on the electron. What do I have? Q6. Power what? Negative 6 over. What is the distance between the 6 and the electron? Okay, and that's what we are looking for. But it's r equals to 15 times 10 to the power negative 6. What is the distance between the 15 and the r? Remember, the whole distance is what? 0, 1. 1 therefore will be what? 0, 1 minus what? R. Okay. Electrostatics examiners love. What are you going to do? Don't think of foiling. I'm just going to exchange. I'm going to bring this here. All the r's must be on one side. So what would I have? 0, 1. This is met. Now my laws of exponent. Do you notice they're both squared? I'm going to say 0 r over r. Please go through this again. Five over 2. What would I do from here? Square root both sides. What would that give me? 0, 1 r square root of what? 5 over 2. What's the square root of 5 over 1,58. We're not rounding off, right? Remember? 1,5811. Oh, this is now sweet. Have. Can we cross multiply? 1, that r over there. 0, 1 r. 0, divide both sides by 2,58. The r over. Let's move this r over here. One plus 1 will give us what? Our answer must be smaller than 0, 1, otherwise 3,8. So 0,038. I wanted to take note of the math, take note of what we did. Don't foil. Is that okay? We are using a simple principle in math that says a squared over b squared equals to a over b also. That's the math principle. I hope this makes sense, guys. I hope you've taken time to go through that one lesson that is on the web. That is, but you need to know it because you would learn what happens when a magnet moves in. By the Lenz's law. Please go and watch that thing before you write. It's going to be about 5 marks there, but it will be there in multiple choice. Okay. It will be there in multiple. Let me give you, I'm going to send you 20 multiple choice questions that you should do. I'll match them together, give you 20. And then you see which topic you need to quickly. Because I know calculations, guys, most of us are quite okay. But multiple choice will test the content. Right. Okay, guys, those of you that are writing on sometime this week, I'm sure go through what we've done so far. I think we've had about 3 sessions. We've done all the vectors, done electrostatics, done electricity, all sessions. I will just make sure I post on a private YouTube link, pending the time that you can quickly have access to it. I'll post today. Now, once you guys leave. That quickly so that everyone is on board. I don't want anyone to be left. That link to go through the revision packages. All right, guys, have yourself a lovely evening and please rest. Rest. And don't go early. Don't run away from school, please. Okay. Speak to Rashida.